So welcome to this latest video on 162 Maths, and in this video we'll be continuing with the series of going through some GCSE Maths higher past exam questions, looking at some big mark questions. Now as always there'll be a copy of the questions for you to have an attempt at before watching through this video, which I strongly recommend you do, and all you need to do is just simply click on the link in the description. Now just a little reminder that you can have access to a copy of the questions by clicking on the link below, and I'll also include the mark scheme, as there sometimes is more than one way to get the correct answer, and I'll only be going through the one that's probably the most common and probably one that's most efficient, but if you've gone a different method you could still get full marks from it. So going through the questions, some of these questions are pretty much unique to one particular topic. So question 1 looks at bounds and again mildly with regards to unit conversions. Question 2 is a big trigonometry question. Question 3 is equation of a line. Question 4 is direct proportion, and question 5 is a speed time graph with a mixture of area, which is quite common because the area under that graph is going to be the distance, and looking at equations. Now I encourage you to make sure that you've attempted these questions before watching through this video as we go through the answers, but if you've not had a chance and you don't have the opportunity to print out these questions, then feel free to pause the video as I read the question, have an attempt at it, then unpause so we can see whether you are right. So looking at question 1, it says in this question use that 1 pound equals 0.4536 kilograms and 1 inch is equal to 2.54 centimeters, and it says the pressure of a basketball is 7.5 pounds per square inch. Work out the pressure in grams per square centimeter. So what we need to do here is look at the units that we've been given. So we've been given these conversions, so we're going to be using these in some capacity. And we want to work out the pressure, and we want that pressure in grams and in square centimeters. So what I need to do is I need to convert the 7.5 pounds per square inch into grams and then square centimeters. So let's have a look at this then. So looking at 7.5, and that's in pounds per 1 square inch. Now first things first, what I want to do is I need to convert that into grams. So the first thing I'm going to do is first of all convert 7.5 kilograms into pounds, and I'm going to do that. I've written that there, so let me just correct that into pounds. And what I need to do there, well, I'm going to do 7.5 multiplied by 0.4536, and if I type that into my calculator that gives me 3.402 kilograms, and then all I then need to do is convert that into grams by multiplying by 1000, and that equals 3402 grams. So I can write this number as 3402 grams. Now for the next one, I then need to convert 1 square inch into centimeter square. So for this, what I need to do now, if you're struggling in terms of conversion and knowing what's what, well, if I draw 1 square inch by 1 square inch, then that's going to be 1 square inch. Then if I convert that into centimeters in terms of the lengths, well, that's going to be 2.54 centimeters, and that's going to be 2.54 centimeters. So then to work out the area, that's going to be 2.54 squared, which equals 6.4516, and that's centimeter squared. So this number here is going to be 6.4516, and then all I then need to do is type this into my calculator. So if I then do 3,402 divided by 6.4516, it will give me my answer of 527.3, and that's in grams per centimeter square, and that's to 1 decimal place. Moving on to question 2, it says 2 triangular lawns are shown. Wire fencing is needed on all 5 sides. Wire fencing is sold in 50-meter rolls. Work out the number of rolls needed. So let me just zoom out so we can see all of this question and watch it convert. So looking at this, what I need to do is I need to work out these 3 sides. So I'm going to call it X, Y, and Z. So let's first of all work out X first. So if I take that right angle triangle and give it a quick rotate. So that's going to be 40, and then trying to picture which other sides are. So that's 100, and X is the side that's got the 40 degrees and the right angle. So looking at this, I'm going to be using, well, labeling, that's going to be the adjacent. So I'm going to be using cos 40 equals, and it's going to be X over 100. So X equals 100 times multiplied by cos 40, and that gives me an answer of 76.6 meters, and that's to 1 decimal place. I then work out y. So again, I'm going to use the same triangle. Let's try and draw that a bit better. Now you don't have to draw the triangles, it's there to help you. So if you can do it straight from the diagram, that's going to be absolutely fine. So that's 40, here's the right angle, that's 100, and this side here is y. So labeling this up again, that's going to be h, that's going to be o, this is theta. So in this case, I'm going to be using sine. So sine 40 equals y over 100. So y equals 100 multiplied by sine 40, which gives me a y value of 64.3 meters, and that's to 1 decimal place. So the next thing what I then need to do, so let me just write this in, and that's 64.3, and this value here is 76.6. So if I take the other triangle that involves z, then this length here is 64.3, this length here is 120, and this length here is 30. Well, here I'm going to use the cosine rule to work out z. So z squared equals 64.3 squared added to 120 squared minus 2 lots of 64.3 times 120 multiplied by cos 30. Now if I type that into my calculator, I get a z squared value of 5169.98, giving me a z value of 71.9 meters to 1 decimal place. So then the next thing I then need to do is to work out the total fencing needed. So total fencing needed is going to be all the 5 sides added together. So I've got 100 plus 120 plus 76.6 plus 64.3 plus 71.9, and I'll add that all together and I get a total of 432. Let me just make that 3 look like a 3. 132.8, and that's to 1 decimal place, which it's going to be. And so from this I then need to work out number of rolls. So the number of rolls needed is going to be 432.8 divided by 50, and that comes up to a total of roughly around about 8 point something. So let me just type that into my calculator quickly. Divided by 50, and that equals 8.656 rolls. But we're looking at exact rolls, so therefore 9 rolls are needed. And there's my final answer. Moving on to question 3, it says that ACB is a straight line. A is at the point 0,8 and B is at the point 40. C is the midpoint of AB. Line DCE is perpendicular to the line ACB. Work out the equation of DCE. So what I need to do is I need to work out the equation of this blue line. So to work out the equation of a straight line, I need to know the y-intercept, or I need to know the gradient and a coordinate that it goes through. So the line DCE is perpendicular to AB and passes C, which is the midpoint of AB. So let's first of all look at the gradient. So here the gradient of AB is going to equal to, so again looking at the height and the base of that triangle, it's going to be 8 divided by 4, and the line's going down, so that's going to be negative, so it's going to be -2. So therefore the gradient of DCE is going to be perpendicular to that, so it's going to be -1 over -2, which is positive of a half. So that there is my M. So here M equals a half. So that's this first one done. So the next thing I then need to do is work out the midpoint of AB. So here the midpoint of AB, well, half of 0 and 4 is 2, and half of 0 and 8 is 4. So therefore the coordinate then is going to be 2, 4. So then using y minus y1 equals mx minus x1, where m equals a half and the coordinate we're using is 2, 4. Now alternately you could have just used y equals mx plus c, it's entirely up to you, but I much prefer using this formula. So here we get y minus 4 equals a half x minus 2. So then expanding the brackets out, oh, don't know, I've put an equal sign there, let me get rid of that. So I get minus 4, a half times x is a half x, and a half times minus 2 is minus 1. And then taking the minus 4 over to the other side, we get plus 3. So the equation of the line DCE is y equals a half x plus 3, or you could write it as y equals x over 2 plus 3. You could even write it as 2y equals x plus 6. So any of those would be absolutely fine as the correct equation. Moving on to question 4, it says the time of each swing of a pendulum, length L centimeters, is t seconds. T is directly proportional to the square root of L. When L is 64, T is 1.6. Work out the value of T when L is 132.25. So looking at this, what we're going to do is going to write this using math notation. So T is proportional to the square root of L. So then swapping this, we get T equals K root L. Then I'm going to substitute these numbers in. So I've got 1.6 equals K of the square root of 64, which is 8. So 1.6 equals 8K. So K equals 1.6 divided by 8. So K equals, and that's going to give me a value of 0.2. So from this, what we've then got is a formula of T equals 0.2 the square root of L. Then substituting the L value of 132.25, so T equals 0.2 multiplied by the square root of 132.25, and if I type that into my calculator, 0.2 times the square root of 132.25, I get an answer of 2.3. So moving on to our last question, it says here is a sketch of a speed time graph for part of a journey. The average speed from 0 to t seconds is 7.2 meters per second. Work out the value of t. Now what we need to do here is basically work out the total area of this, of under these lines, and we know that the total area is 7.2. So if I start by just labeling these three main areas, now A is a triangle, so the area is a half base times height. B is a rectangle, so that's just base times height. And C is a trapezium, where it's A plus B times H divided by 2. So let's start by working out the area of each of these sections. So this is 8, and look, using the coordinates, the length is 9, so it's going to be 9 times 8 divided by 2, and that gives me an area of 36 meters. Then looking at the rectangle, well, that's got a height of 9, and looking at the base, which is 14 take away 8, which is 6, so that's going to be 9 times 6, which is 54 meters. Then working out the area of C, well, this is a trapezium, so this length here is going to be 9, and this length here is going to be 7, and the height of that trapezium is t minus 14. So then substituting those numbers in, I get 9 plus 7 multiplied by t minus 14 divided by 2. Now just simplifying all of that, what do I get? Well, I get 9 plus 7, which is 16, t take away 14 over 2. Then I can cancel the 16 and the 2, so that becomes 8. So I end up with 8t minus, and that's going to be 8 times 14, which is 112. So this length here is going to be 8t minus 112 meters. Now to work out the average speed, now average speed is the total distance divided by the total time. Now the total distance is the total area, and the total time is going to be t, because it's going from 0 all the way to t. So let's now just substitute those expressions in. So the total area, or the total distance, stroke the area, is going to be 36. Oh, don't know what's happened there. So it's going to be 36 plus 54 plus 8t minus 112, and that gives me an answer of, altogether, it's going to be 8t minus 22. Now from this, what we can then do is work out the average speed. So the average speed is going to be 8t minus 22 over t, and that's going to equal 7.2. So then now if I turn this into a fraction, which use a different colour, put that over 1, I can then cross multiply. So I've got 8t minus 22 equals 7.2t. So then from this I get 0.8t equals positive 22. So t equals 22 divided by 0.8, and if I type that into my calculator, I get an answer of 27.5.